Morning, welcome everyone. Give it just a minute or two to make sure everyone's able to log in and join before we get started. We were just told that there were over 80 registrants for this webinar. We really appreciate your time. I think the average webinar attendance monthly is probably closer to 20. So 33 are in. We'll give it just maybe one more minute. For the sake of honoring everyone's time this morning. This afternoon, I guess, for some of us. Yeah. All right, let's get started. Anyone else that joins can catch the recording on what they missed. Good morning, good afternoon, everyone. Thank you again for joining this webinar as we discuss solutions for processing embedded batteries in devices, and in reality, loose batteries as well. My name is Jeff Gloyd. I think I know I've met many of you on the call. I've been part of NAMA for close to 20 years, on the board of NAMA for probably 15 or 16 of those years. And joining me on the call today is my colleague at Gloyd Recycling, Andrew Spencer. He's our Director of Innovation and Growth, and was integral in the design of the system and what it how making sure that its capabilities match the need in the market. Just a little background. I've been in waste and recycling industry for about 25 years, run landfills, hazardous waste facilities. That's when I got into NAMA, medical waste operations, and the last decade or so has been directed towards running large scale e-waste shredding operations, hence the experience with thermal events. We don't like to say fires. I'm learning that in some places around the world they call them percussions. But if you touch or deal with electronics from a collector or processor standpoint, you will have thermal events, either in your process equipment or during the collection and the disassembly process, or heaven forbid, while the material is being stored in paled boxes long term until you build a large enough load for shipping. I'm going to venture a pretty obvious guess here that not anyone on this call hasn't heard of the struggles in dealing with particularly lithium primary batteries. It seems like every time you open a waste association across the waste spectrum, a journal or read an online newsletter, there will inevitably be a story about an issue with a battery, a fire in a truck, a fire in a building, or a fire in a shredder. We started looking at this more directly on solutions about two years ago. And what you'll see today will be just 6 slides. So we'll go through it quickly. Hopefully it'll generate some questions, and we'll leave lots of time at the end for a question and answer session. Okay. Most of you already know this. I'll go through it as quickly as possible. What is the problem? Small form factor batteries, embedded devices, they are everywhere and they're growing. If you've dealt with electronics collection, what you've seen in the last particularly 5 to 7 years is that your weights tend to be decreasing, but your piece count tends to be increasing substantially. And all that means is that things are getting smaller and lighter. And as things get smaller and lighter, we see more and more of those devices having embedded batteries. Many of those embedded batteries, because of the strength of battery and life of battery, end up being lithium batteries, which can cause the problems that we're talking about, particularly related to fires and thermal events. It's particularly mixed in material. So if you're trying to determine if this kid's toy or this vape or this wireless cordless kitchen appliance has a battery, it's also going to be mixed with toys and kitchen appliances that don't have batteries. So there's a struggle many times with identifying, where the batteries are in the waste stream and feedstock in the return material, and then trying to remove those batteries as well and determining what chemistry they are. Small weight, massive quantities. So we'll talk a little bit here in the next couple slides about current solutions and what's happening. If you're operating collection sites and you take electronics, you have heard from battery recyclers. There's a few large ones. A couple of them have been around for decades. Two of them are fairly new to the market. They want clean, sorted chemistries. And if you read articles and you see their operations, they're really designed for large format batteries. So EV batteries, the government spent $4 billion building EV plants. And no one seems to be addressing the larger problem, which is these small form factor batteries and batteries embedded devices until we've come up with some solutions. Mixed battery chemistries as well. It's difficult and time consuming to sort them, take them and store them. If you've dealt with recycling of batteries, the value in a nickel cobalt battery has been decreasing. The cost of managing a non-nickel cobalt battery, an alkaline battery, a primary battery, NiCad battery, a lead battery have been increasing as well. Also deal with high production costs of removal of the batteries. If it's a Gaylord full of DirecTV remote controls, there'll be 1,500 remotes, and we've done this. I've done this before, and the staff have done this before. Of those 1,500, 80% will have alkaline batteries. Another 10% won't have batteries at all, and then there'll be 10% that are some form of lithium primary or lithium ion battery. And the cost of managing that is astronomical. It might take a single staff person a day and a half to sort through one pallet. So you're talking, $20, $25 worth of all-in FTE cost. You're talking about, $600-700 worth of staff cost to manage one pallet of remote controls. Extremely costly. If the batteries are in devices that are not intended to be open, think of certain phone brands, think of AirPods or other earbuds, think of water meters. Many of you in municipal programs are dealing with large number of water meters as the government's doing change outs. Those have an exterior application and are designed specifically to be sealed to prevent water from accessing the circuitry and, of course, the batteries. And to manually open them and remove them is extremely difficult. And right down the line, e-cigarettes is a major problem for many collection sites. Again, they're not designed to be easy. The batteries are not designed to be easily accessible, which leads to a high cost of removal in a lot of time. Exporting. It's not supposed to be happening, but there are companies in the U.S. that will gather up this low-grade material, embedded devices, and simply push that burden onto developing countries. It's something that some of the regulatory bodies, some of the e-waste certification bodies in particular, are starting to address more directly, but it does happen. And when that happens, we are putting burden onto areas that may not be equipped to manage those burdens. And also, we're losing access to some of the critical materials that we want to maintain access to in North America, particularly nickel, cobalt, and lithium. Risk of thermal event of staff on large equipment fires kind of started this presentation. Don't have to go into depth in this. If you're opening charged batteries in phones, and in a process you nick that battery, it will flare in your staff's face. I've seen it hundreds of times. At the same time, you want to improve safety and guarantee safety and hit production targets. It's hard to ask a staff person to work quickly to hit production targets when there are literally lithium fires flaring in their face on a regular basis. Uh, you know, you can read some EPA reports and other reports about how many fires there are in facilities. You know, one says 300, one says 5,000. The actual number of fires is much greater than that in reality, and leads to a significant amount of downtime and loss revenue as well. And you know, I'll throw a couple of slides here. This is from Fire Rover. Again, I think there's a lot more fires, but what we're seeing in the market, if you run a warehouse that deals with battery containing devices or batteries that are loose, what you're seeing is some insurance carriers not underwriting your site at all. You lose access to insurance providers. And even reactive systems like a water suppression system after a fire happens are not impressing the underwriters. And what we're seeing is those who continue to insure waste and recycling warehouses, we're seeing costs go up fourfold, sometimes more. Did mention briefly current practices. So what's happening right now? Well, it's a very manual process. The large battery recyclers, as I mentioned, want separated batteries and clean chemistry. So I want mixed batteries, and it won't take batteries embedded in devices. If they do, the cost is typically around $1.80 to $2 a pound for them to manage the disassembly. And what they're doing oftentimes is sending it to others to do that work so they can get the batteries back. What does that do for the suppliers? For the companies that are sending these devices? What does it do for municipalities that are managing? It's a very, very high cost for the person who's providing the batteries to a battery recycler or an e-waste processor to remove the batteries from devices. If someone's charging $1.80 a pound for a mixed toys, you're not going to see as many mixed toys in the stream. Many folks will choose the lesser of the two evils, which is simply putting it into a landfill. So we're leading to less collection because the cost of managing embedded devices is astronomical. Excessive labor, we've mentioned, it's just, I've been in facilities, I've run facilities where there's 20, 25 staff full-time just removing batteries. What happens if you remove the batteries? You sort the batteries. After you sort the batteries, you have to tape the batteries. If you tape the batteries, you have to put them in 5-gallon belts and store them for long term because the battery recyclers want full truckloads of batteries, which is typically 20 tons, opposed to 40,000 pounds. It's a lot of batteries to be storing in your facility before you ship. There's no doubt that that is leading to some of the warehouse fires that you read about that are catastrophic to individual businesses. I mentioned briefly the reactive systems, high volumes of water or chemical suppression. They can be very effective at making sure the warehouse isn't burned down completely, but being a reactive system, what are you left with as an operator after the fact? And it is, I guess, in a word, 2 words, a mess. 10,000, 20,000, 30, 40, 50,000 gallons of water or chemical suppression, filling your warehouse, contaminating your feedstock, your supply, wrecking your gallon boxes. It can be a complete disaster, although can definitely save the warehouse from complete destruction at times. Then the question becomes damaged batteries. Yeah, you can look at all of these current practices and say damaged batteries oftentimes have to be stored in special containers by themselves. The cost of managing it usually has to be done through a hazardous waste operator, and the cost is astronomical. And you're storing it until somebody is able to pull that off the site for you. It's the good parts, and hopefully what generates some questions. So what can be done about it? Right now, there's nothing in the market at the warehouse level that can help solve some of these problems, from cost to storage and risk to maintaining access to commodities, including the black mass containing lithium, nickel, cobalt, and zinc and manganese and other metals. 2 years ago, 2.5 years ago, we started thinking we need a solution that is CapEx affordable, it's simple to operate, is built to manage the battery containing devices that are the size of a laptop base and smaller, not focusing in any large form factor, just focusing on a large volume of small batteries and batteries embedded in devices, ubiquitous equipment, and doing it at the warehouse in a unit that covers a very small footprint so that it doesn't interrupt the operation, doesn't require additional power, it doesn't require additional facilities to run the process. And this is what we came up with. We came up with a wet battery shredding system. It's not new technology. Wet shredding of batteries has existed for a very, very long time. Fitting it on a platform that's only 240 square feet, so it doesn't take up a lot of room in your warehouse. It can ship in a 40-foot shipping container for international applications, all in one piece on a skid. Skid slides off, bolted to the ground, plug it in, add some water to the water tanks, which we'll get to in a minute, and you're ready to start running material. We want it to be simple to implement, cost-effective to purchase, and easy to operate. How do we make it, long-term sustainable for an operation to be interested in something like this? Well, we need some kind of return on investment, and ROI was important because simply wet shredding batteries and battery-containing devices to deactivate them can be done. At that time, you could just be getting a blob of plastic, metals, black mass, critical materials that becomes less valuable, almost no value if it's all mixed. The design here is to deactivate the batteries through the shredder and then recover 3 commodity streams at your warehouse. You get a black mass through a filter press. You get plastics that float in a density tank, and you get mixed metals, and including ferrous, non-ferrous, and precious metals. That would be on circuit boards, gold, palladium, platinum, silver, and copper that would sink in the density tank for recovery. So 3 commodity streams that you get to keep: black mass, plastic stream, metal stream. The value of those are solely dependent on what you're running. If you're running phones, tablets, you're going to get a very high value black mass. It's high in cobalt. You're going to get a very valuable metals because it's a very high quality circuit board and aluminum, and you're going to get typically fairly valuable plastics. If you are running mixed kids' toys, which is mostly plastic, maybe a little bit of ferrous and very small low-grade circuit boards, you'll have a lower value metal. You will have some plastic that has value, and you'll typically have a lesser value plastics. At the end of the day, the entire idea and concept of this system and the excitement behind it has been that you no longer have to line up 25 staff over 10 or 15 and ask them to sort material, batteries, non-batteries, remove those batteries from devices like phones and e-cigarettes and water meters and kids' toys, drones, etc., and then take and store those batteries to ship downstream, many times at a cost to your operation. You can manage all of that process simply by putting that material mixed into the bids system. You'll see I'm not sure if you can see the pointer, but on the left side is a feed hopper. It auto feeds with a VFD, so you can change the speed of the belt feed. If you have lighter material, you can run it faster. If you have denser material, you can slow it down. If you have highly reactive batteries, like the ones that come out of water meters, you want to slow it down. That feeds into a wet shred system. We're pumping about 32 gallons of water every minute, deluging the system, which suppresses the thermal events and deactivates the batteries. That water in that system also slurries the black mass that is broken, that is removed from the broken batteries. So you get a slurry of black mass containing the lithium, cobalt, nickel, zinc, manganese, other metals that runs through a filter press, which you see here, and then circulates back in through a wet scrubber for emissions control, and then back into the wet shredder. So it's a closed system that deactivates and shreds the material, collects the black mass, and then filter presses the black mass into a cake that can be recovered and refined. The solids from the shredder fall onto a shaker table. That shaker table falls into a density separation tank, a separate water tank that has a certain density, a salination level that would make lighter plastics float to the top, where they're skimmed off and collected in tip hoppers, gaylords, or super sacks, however you'd like to collect it. And the density is set so that heavy materials like circuit boards and ferrous and non-ferrous metals, also dense plastics, would sink to the bottom, where they're augered out again into a tip hopper or into a gaylord or into a super sack for recovery. Anticipate that for most operations running between 1,000 and 2,000 pounds an hour. So that's 2 million to about 4 million pounds a year worth of low grade or small form factor devices and with embedded batteries. That the return on investment would be between 12 and 36 months. We do have a few US patents on the system and have a contract for 4 units in hand with five, it's actually more than 5 now. This is a slightly older presentation. There's about 10 companies that are also interested in looking at a unit like this. I want to mention just a little bit, and I'm sure there'll be some more questions about the specific operations that I'm sure that myself and Andrew can answer on this call. But who might benefit from using a system like this? So clearly, folks that are in the e-waste industry, they see a lot of this material from consumer collection events. They see a lot of this material from business contracts. They certainly see a lot of this material from retailers. If you run collection events for a Staples or a Best Buy or Amazon or Target or Walmart, a majority of the material is going to come in mixed low grade, and a lot of that material will have embedded batteries. So certainly e-waste processors themselves would benefit from having these at the warehouse level. We're also seeing interest from contract manufacturers. So these are the folks that actually put phones and the earpods, earbuds and other equipment, electronic equipment together. They have off spec, they have trials as building these new electronics, but they also have many times take back programs as well, and don't have solutions for the material that has batteries embedded in them. We're seeing interest from manufacturers themselves. So folks that make phones and tablets, they oftentimes, again, have take back programs through the retail operations, and they like to be able to manage much of this stuff, much of this material in-house. Right now, they're paying very high fees to gather material, ship it across the country, and have it managed manually. So they see some value from a brand standpoint, managing and maintaining access to the metals, but also as cost savings potential to reducing their costs and labor for a third party to manage these devices for it. What's next? So we're starting to build the first units. We have contracted with a contract manufacturer out of Michigan. They're going to be built in the U.S. With essentially parts that are off the shelf, plus the fabrication of the tanks and other systems to make sure that the unit fits within the parameters of the 240 square foot skid. Our manufacturer has the ability to place up to 10 units by the end of 2024, and we're thinking expanding into about 30 units per year. So there's a lot of capacity to turn these over quickly if the demand for the units is there. One of the things I didn't mention was, which may answer some questions, is that it is a net consumer of water. You will not need a water discharge permit, even though there's 2 water systems, the freshwater system and salination density system. And you will not need an air permit, because you do not need to vent. Well, in most states, you have to check your state regulations, obviously. but you'll vent the air back into your warehouse, just like a standard e-scrap shredder or other processing unit. So you typically would not need to have an emissions permit. You may need exemption permits, but most of you that have run warehouses are already used to that process. You're not discharging anything but potable water. You still might have to have an exemption permit, but you don't have to get a discharge permit. Once the water does get a little bit grimy and dirty, because you imagine these things are, this material is very dusty. You'll get some fine particulates from the shredder coming off the circuit boards and the other plastics and the metals as well. So the density tank will become too dirty for it to operate efficiently. At that time, we'll have recommendations on when that is and sensors that tell you when it needs to be cleaned. That tank needs to be drained. It's about 1,500 gallons. You have two options. You have an option of draining that tank into either sea containers or other totes, and then working with a local or regional processor to test that water, determine if there's any hazards. If not, then they can discharge it under their permits. Many of us have done that with other programs and systems. That cost could be $90 a tote. That could be $1,000 a tote, depending on what state you're in, depending on how far you are away from somebody that's able to provide that solution for you. That's one option for cleaning the water. The other option is we're implementing a water management system that essentially would evaporate the water and leave you with a cake from that water. It's going to be a high concentration of salt, obviously, because it's a saltwater tank. You evaporate the water, you're left with the salt, but it will also be left with any of that particulate and precious metals, possibly some black mass that gets into that system. And then it could be tested again, could be landfill, could be hazardous waste landfill if required, or it could be sent for metal recovery, depending on the amount of metals and precious metals in that case. So this is kind of an add-on that Andrew and the engineering team are working on for those who want to be able to manage the water in-house versus containerizing it and shipping it out for the third party. We mentioned some of the use cases where these units are being placed. Some e-waste folks definitely have other metal separation. So when they get a mixed metal, they can take that out of the system and then run it through their own shred systems where they have mag belts, eddy currents, and optimal sorters, where they can get a cleaner aluminum, a cleaner steel, and a cleaner circuit board and a cleaner copper wire product for sale to regional and global markets. Not everyone's going to have access to that level of equipment. We are looking at working with some iPad providers. Those are folks in the e-waste business that do a lot of refurbishing and reselling of devices. Well, they have cut lines, and then below that cut line, they have to send for end of life. Many of those items contain batteries, and there's a potential extreme increase in value for them to manage that end of life product at their warehouse. They would not have the equipment to separate metals. They don't have eddy currents. They don't have mag belts. They don't have the sorters for cleaning up the metal stream. So we're looking at designing a second module, which will contain equipment, eddy currents, centrifuges that can not only recover different metal streams, but can clean them up to make them more marketable, more valuable, but also centrifuges that can concentrate the valuable metals in black mass, concentrate the lithium cobalt while separating the lesser no value black mass components like graphite and carbon. So that's again kind of the next level of making the system more efficient and being able to provide a solution, higher value commodities to folks that don't have those systems already built in their facilities. The last one is there's other technology that can help streamline the process as well. Visi and Livinit, and we've done some work with them, doing some work with them currently, developed hardware and software AI programs that through an X-ray system can identify the low-grade material you're pushing through the unit, which units have batteries and which units don't have batteries. And when it determines what battery, when a unit has a battery in it, a phone or a drone or a wireless keyboard or a mouse or a remote control, it it shines a laser on it, and your staff knows, oh, there's a battery in here. It also has the ability to identify different chemistries. So you can do some sorting at the sort table after the X-ray. So now you can let all of the non-battery contained devices fall off the system while you're pulling off the battery contained devices, or vice versa, depending on how much of it you have. And you're only processing the battery containing devices through the bid system and manage the non-battery containing through your typical e-waste operation. It really pairs well together in identifying what has a battery in it and then managing that battery at the warehouse level. All right, that was about 30 minutes. I think that covers most of what we want to go over. There's clearly a lot more detail in the system. Let's see if there's some questions. So one question, can't damaged batteries be managed as universal waste? I'll answer that in that I think yes, depending on the state you're in, but that's not my concern. My concern is if you have a damaged battery, so let's say a bloated battery, your battery recycler is not going to be interested in that, and you're not going to be interested at the same value. They might not be interested at all, but it also poses an extreme risk to your facility because if that bloat turns into it popping, then you're going to have a significant thermal event. That battery in that situation can go into this system and is managed at the warehouse level. And that's where we see some significant advantages. Next question is what are the permitting requirements for facility that houses piece of equipment? Shredding is considered crossing under RCRA, question mark, yes or no. So when it comes to permitting, we don't want to overstate or maybe simplify the situation too much. The requirements of running shredders varies greatly by state. If you're in California, love California, but they don't like putting shredders in. It's just very, very difficult to get an approval for shredder, which is why you see operations popping up in Nevada and Arizona and Oregon. Other states have different requirements. Company I recently worked for, we put 4 large-scale shred operations in Georgia, in Illinois, in Texas, and in Nevada. And each one of those states requires slightly different, somewhat similar, slightly different permit requirements to be able to operate those shredders. So one thing I will say is that I've got a lot of experience with that. Andrew on the team and others have a lot of experience with that. Before you ever go through with a proposal, we could help with the process of really understanding what it would look like in your community, municipality, in your county, and in your state. We'd certainly be willing to help in that process. This is a great question, which I was going to get into. My friend Julie Mitchell up in Seattle. Do you see municipal hazardous waste collection facilities, HOW sites fitting into usage of this device for me to look at our hazardous waste vendors to contract with a company using this technology? The simple answer is both. We have been in contact or been contacted by a couple of hazardous waste RCRA permitted operators who are interested in this unit because of the fact that they deal with their own kind of e-waste collections. They want to tweak the system a bit to be able to manage hazardous waste batteries like nickel cadmium. I don't recommend that for the normal user, but they have the ability to treat the water, so it's a different application. But if you have a hazardous waste provider that is looking into the system, that could be a very, very good partnership because that's going to lower your cost dramatically. You will, however, still need to manage the storage of this devices. You have to manage the risk conversation with the ability to possibly lower your costs and not have to, manage the CapEx on a system yourself. On the other side of that coin, Julie, and for the rest of the group, I think there can be applications. The unit can manage, about 2 million pounds on average a year of battery contained device. And if you think about that, that's a lot. An iPhone weighs a third of a pound. It's a lot of icons. Most HHW facilities, even when you look at its toys and kitchen appliances, vapes and water meters, are typically not going to see 2 million pounds of battery containing devices. However, if you're in Iowa, for instance, and you've got a great program in Quad Cities, maybe there's a partnership with your friends in City of Dubuque and some of the surrounding other communities where it could be a joint venture where there's a unit purchased. And because of the collection network, you know there's going to be about 2 million pounds of battery embedded devices. I think a consortium like that would work very, very well in the HHW world. And I think it's something that I'd be happy to discuss in more detailed thoughts on that. I've given some thought to that. I've talked to some friends at NAMA and others about that idea in the past, and that might actually work out well. Electricity requirement, phase, voltage, amperage draw. I'm not going to share this this call. I don't have the last name, but Paul, if you want to reach out to me afterwards, we have a spec sheet. We just want wants an NDA is required, but I will share with you generally. Most of the motors are pretty small, so we're just talking about moving paddles and augers and conveyor belts. The shredder itself has two 50 horsepower motors. The electrical draw essentially would be about the same as running a portable welding system. So if you run one of those in your facility and you have enough power for something like that, that's all this unit would draw. And I can get you more details on a one-on-one conversation.
And the one thing I'll add on that there for you, Jeff, too, is the system's going to be powered by one location, and it's just going to be a welding receptacle. So if you have a welder at your site, it can plug right into and power this entire skid.
Yeah. Here's a good question from Paul as well. Why don't you show a video of the machine working? Very good. The first machine is actually being built today, or being built, in real time. We released this product after spending 2 years of engineering it. We released it in January, and there was a significant amount of interest. As you can imagine, I can see there's different participants on this call. It's a big, a very difficult topic in the industry, across industries right now. We've seen a tremendous response. We've got the first orders. We've signed contracts with manufacturers, with critical components, shredder head companies, the filter press companies, the emission control companies, and we're moving forward building the first units. Now, I say that with high confidence that one of the things that the buyers of the units have allowed us to do as early adopters is we're going to have lots of videos here in the next few months as the pieces come in and they get put together. We'll be able to release a lot of videos of that process, and we'll be showing the unit tested working along with specific processing streams, let's say recipes. So just phones and tablets, just low-grade toys, et cetera, et cetera. So we'll have a good value prop with the commodities. So we'll know what the black mass is worth when we run X, when we run Y, when we run Z. We'll know what the metal's worth, what the plastic's worth, et cetera, depending on these different blends of product in the system. So stay tuned. If you're interested in waiting to see a function unit, we're probably about 4 or 5 months away from having a fully developed function unit, and there will be videos and site tours available for you to see the unit operating. And again, one of the things let's add to that is every unit will be tested working at the manufacturing site before it is put on a trailer or in a container to be sent to your operation. And lastly, to belabor that point, you can have your staff there watching it. Yep, I see it working. Let's box it up. Let's get it to our site. What's the volume of batteries needed to make this cost effective? X pounds per day per year. Okay. So if we manage on the low end about 1,000 pounds an hour, that's 2 million pounds a year. We do 240. That's 8 hours a day, one shift. So we can do more than one shift. Obviously, I wouldn't do 3 shifts, but you can do 2 shifts for sure. But 2 million pounds would be about 240 day working year, right? So if you have 2 million pounds of material, the cost of running this system doesn't really change depending what you put in, right? That's one of the nice things about the operating system like this. The cost of running or the costs of running it. our estimates are the cost is going to be on the high end around 15 cents per pound. We also estimate that on the low end, the commodities alone will be worth somewhere around 25 to 30 cents a pound. Now, factor in that many of you also are charging residents or businesses for receiving, or you get grants from the state, or if you're in Canada, the province pays for EPR programs paid for some of this material. In 25 states in the US, the EPR programs paid for some of this material. We've seen Wisconsin has added battery energy devices. New York's done it. There's a number of states that don't, but some are moving in that direction. So you're getting paid somewhere between, we'll say, from my experience, 8 cents to 29 cents a pound to manage this. If you're processing it in-house, it's costing you 15 cents a pound. You're getting the upfront fee and you're getting the 30 cents per pound in commodity value. So we have ROI calculators where you can kind of make adjustments based on what you've seen. You do a lot of phones, do a lot of a water meter, do a lot of e-cigarettes, or do a lot of low-grade kids' toys. What do you charge or what rebate for that? You can plug all of that into our ROI calculator and it'll kick out what that return will be. Again, something that if we connect offline, and we'll be happy to share with you and your teams. If there's a mobile incident batteries in the road is really cleaned up on site. Oh, okay. I think I understand this. The question is, could this unit, because it's compact and can be transported in a container or on a flatbed, can it be mobilized? And the answer is right now, it's not designed to be mobile. There's a couple things. One, you want to address permitting. Two, you do have to have about 2,000 gallons of water. So there's an issue of how do you get the water? How do you salinate the water to the proper level so that it can work properly? How do you manage that water after the fact? And then, of course, getting to a site and powering the unit. You got to have to make sure you have enough power for the unit. That said, Andrew is literally working. We'll call it bids 25 or 24 and a half or something. Literally working on a mobile unit that does exactly that. Now, there are two use cases. One, it could be available for emergent situations. If you had 10, 15, 20 of these strategically placed around the country, you could probably use it as emergency response for sure. But there's also, I think, an advantage for particularly the HHW world where you're not seeing tremendously large volumes of this material, but you're storing 5 or 10 Gaylords and you're storing it for a long period of time until your in-strat provider comes and picks up material. If we had mobile units, again, staged 10, 15, 20 of them strategically around population bases or where there's volumes of material collected, even if it's not large populations, we could develop a system where we're doing milk runs, or we're coming to your site with a mobile unit, or someone is, and running your 10 Gaylords, packing up, moving to the next community, running their 10 Gaylords, moving to the next one. And now you're not worried about manual disassemble. You're not worried about long-term storage. You're not worried about transportation. You take that mobile unit and bring it to you. So I think there is some future applications for both emergency response and just having a mobile unit able to manage smaller volumes. Okay, I think that is all the questions that I see on the Q&A section. We're at about 45 minutes. I think that's kind of the allotted time. Again, really appreciate the attendance and you joining us, taking time out of the day. We're excited about this. If you have questions, please reach out. We'd be happy to answer in more detail about the process. We're excited to get the first units located and running and showing everyone what it can do as well. Appreciate it. Have a great rest of the day and look forward to speaking to you.